Okay, so let's now take a look at mass weight density assignment 2. So like the previous assignment, I will only be going through the calculation parts. Okay, those definitions, I'll just let you know the page number and please refer to what is meant by the density of an object. And this definition question can be found on page 57 of your booklet. The SI unit is kg per cubic meter. So for 1B1, it's a calculation question now. So what is the formula? The formula can also be found on page 57 as well. So if you remember this triangle, M rho V. Okay, so the question wants to calculate the density, right? So density is rho, we cover rho, and then we have mass over volume. Mass is given as 1,500, volume is 50. This is pretty straightforward, 30 kg per cubic meter. Okay. So B2, they say given that the density of pure water is 1,000, okay, they want us to state and explain, okay, there are two parts of this question, if the object will float or sink in pure water. So this object density is this. So how do we know whether the object will float or sink? Okay, so if the density is less than 1,000, then it will float. If the density is more than 1,000, then it will sink. Alright, so in this case, of course, 30 is obviously less than 1,000. Okay, so the object will float. This is the stating, because its density is less than pure water's density. Okay, very straightforward. Stating it is 1 mark, and explaining it is the 2nd mark. Alright, so question 2. A beaker can hold 250 cubic centimeter of liquid. Take note of the unit, be very careful. So when it is filled with paraffin of density 0.80 gram per cubic centimeter, so just nice, you see, the unit for the paraffin, in this case the density is in cubic centimeter as well. This is also in cubic centimeter. So the total weight is 2.6 Newton. And they want us to take G, which is the gravitational field strength, as 10 Newton per kg. Calculate the mass of the filled beaker with paraffin. So how do we find this? So mass of beaker with paraffin. So how do we find mass? Mass will be 2.6, in this case, which is the weight. We use the formula W equals to mg. So m is equals to W over g, right? So W in this case given is 2.6, g given as 10, therefore answer is 0.26 kg. So if you're not comfortable with kg or decimal, you can also leave it in grams, but the question did not ask for it, so you can leave in either form. So for B, they asked to calculate the mass of paraffin in the beaker. So how do we find the mass of paraffin? So in this case, we are given what? We are given the density of paraffin. What else? We are also given the volume of paraffin. So mass in this case should be rho times V. Okay, so you must know what you are given and use the quantities that you have to calculate what is required. So the density in this case is 0.80. The volume is 250. So the answer, 200 gram. Not kg, okay? Not kg, because every unit given to you, the units given to you are in grams and cubic centimeters. Okay? You must show your working. I need to emphasize again, calculate. Alright? So you must show your working, and every time when there's a calculation question, my advice is always start off with writing in the formula. So for part C, they asked to calculate the mass of the beaker. So how do we find the mass of the beaker? Very simple. Mass of beaker with paraffin, we minus away mass of paraffin. So mass of beaker is equals to 260 minus away 200, I get 60 gram. Right, easy peasy. Okay, question 3. So question 3 says that an alloy is a mixture of 2 or more metals. Alright, so in the context of chemistry, this is incorrect. It is one metal, or another one, it doesn't have to be metal, it can be a non-metal as well. Okay, but doesn't matter for this question, is we just take it as 2 metals. So one alloy is made by melting 4 cubic centimeter of metal, density 5, and 8 cubic centimeter of another metal of density 6. So you see we have 2 different metals, we have 4 different numbers and quantities now. Alright, so you need to be very clear what's given to you. So let's write it down. Okay, metal 1, okay, volume is 4 cubic centimeter, density is 5 grams per cubic centimeter. Metal 1. So metal 2, volume is what, 8 cubic centimeter, density is 6 gram per cubic centimeter. Alright, so when you sort the things out, the information given to you, it is easier to see, it is less likely to commit careless mistakes. So assuming there are no changes in volume as the alloy is made, so they want you to calculate the mass of the alloy. So since the alloy is made up of both metals, the mass of the alloy will be the sum of the masses of both metals, right? So let's find mass of metal 1 equals to, remember the formula? Mass equals to rho V, okay? So 4 times 5, 20 what? 20 grams, okay? You see? It's given to you in grams. Mass of metal 2 equals to, same thing, rho times V. So in this case I put V times rho lah, 6 times 8, I get 48 grams. So mass of the alloy will be equals to 20 plus 68. Oh, you see, I already thought of the answer in my mind. 20 plus 48 equals to 68 grams. Next, to find the density of the alloy. So to find the density, because this is an alloy, right, the whole thing, it should be kind of quite well mixed. Okay, so density is equals to mass over volume. Alright, we already found a mass which is 68 grams. Okay, but do we have the volume? Alright, we have the volume given separately lah. So we need to use mass, which is 68, over volume. We have 2 volume, 4 plus 8 in this case is 12. Alright, so end up you should get 5.67 grams per cubic centimeter. Alright, so remember to round off appropriately to your number of significant figures. Question 4. Jason floated a piece of cork stopper of mass 2.5 grams and volume 10 cubic centimeter in water. Alright, so this is the first set of data. Okay, this is for the cork stopper. He then stuck some steel pins in the cork stopper. So calculate the volume of the steel pins if the mass is 39.5 grams and the density of steel, okay, is 7.9 gram per cubic centimeter. So they want to find volume, right? So again, M equals to rho V, manipulate a little, V equals to M over rho. So what's the mass given to us? 39.5 over density is 7.9, right? So what do we have? We have 5 cubic centimeter. Pretty straightforward. So for part B, they say to calculate density of the cork stopper stuck with pins. So in this case, we're going to assume, although we're going to stick the pins onto the cork, it's pretty logical to think that the density is not evenly distributed, all right, but let's assume that this is a composite. Okay, the cork stopper together with the pin stuck on it, the density is evenly distributed, the mass is evenly distributed. Okay, so density equals to mass over volume. So we're talking about total mass and talking about total volume. So what is the total mass? What's the mass of the cork stopper? 2.5 plus 39.5 for the steel pins, right? And the total volume, right? The cork stopper is 10 and the steel pin is, we calculated in previous part, is 5. So the answer will be 2.8 grams per cubic centimeter. Okay. Question C. Given that the density of water is 1 gram per cubic centimeter, state and explain if the cork stopper start with steel pins. Okay, so the cork stopper start with steel pins. We're not talking about just a cork stopper. So the overall density, as we found the previous part, is 2.8 gram per cubic centimeter, right? And density for water is 1. So just now we already mentioned anything more than the density of water will sink in water. Anything more less than the density of water will float in water. So in this case, obviously 2.8 is larger than 1. So it will, the cork stopper with pins will sink in water. Why? The total density, all right, of the cork stopper with pins is larger or smaller? Larger than pure water. All right, so that's why it will sink in pure water. Okay, question 5. All right, the diagram below shows 8 spheres placed in a cylinder of water. Okay, so let's analyze the data a little. All right, so this is basically a cylinder. Diagram on the left, this is a cylinder. And then there's water. That's all. What's the volume of water? 23. What's the total mass? 50 grams. Okay. And then for the next one, we have on top of water. So I'm going to assume the water didn't change. All right. They added 8 spheres. Okay, into the water, the beaker of water, the cylinder of water. All right. So now I have a cylinder plus water plus 8 spheres. Okay, volume is now 55 and the mass is now 68. All right, so the only thing that changed is the addition of 8 spheres. So I can straight away see what changed, right? The mass changed and the volume changed. So the question wants us to find density. So how do I find density? Density equals to mass over volume. Do I have the mass of the 8 spheres now? Not directly off the question. Do I have the volume of the 8 spheres? Also not directly off the question, right? So we need to calculate them. So in this case, the mass of the 8 sphere will be the difference of the mass between these two, right? How did it change from 50 to 68? Simply because the addition of the 8 spheres. So the mass of the 8 spheres will be 68 minus 50. Agree? And then the volume, same thing. All right, after adding 8 spheres, the volume increased from 23 to 55. Hence, the volume of the 8 spheres will be 55 minus 23. So once all these are plugged in, all right, punch into your calculator, this and that, I think you should get 0.563 gram per cubic cm. Okay, 3SF. Okay. B, state the density of one sphere. All right, I was marking this and I realized that really quite a number of you did not get this correct, although a handful of you got it right. Okay, so good for those who got it right. So when we read a physics question, sometimes it's very important to really find out what they really want from us. What do I mean? You see, look at 5A, they ask for calculation. We calculate. They ask you to calculate, it means that you need to calculate. I know you can do mental sums, all right? But even if you're doing mental sums, you are still doing calculation in your mind. So this is asking you to state. So in physics question, whenever they ask you to state, many times the answers are pretty obvious. Okay, so in this case, density is a property of a material. The 8 spheres are made up of the same material, therefore the density is the same. Alright, I don't care I'm talking about 1 sphere, 8 spheres or 100 spheres, the density of the sphere is still the same. I do not have to divide by 8. So the density of 1 sphere is equals to 0.563 gram per cubic cm. Okay, so this is a very important concept. Alright, the density will not change unless your material changes. Alright, let's take a look at question 6 now. Okay, a vertical uniform tube of area of cross section. Alright, so the area is 0.25 cubic cm, contains a column of liquid of length 12.4 cm. Okay, so you see the length is like that, base area is like that. Alright, because this is a tube, right? It's supposed to be 3-dimensional. Okay, they give you area, they give you length. I think you can expect to find the volume of the cylinder or the column. Okay, so they tell us that the density of the liquid rho in this case is 0.80 gram per cubic cm. They want us to find the mass of liquid in the tube. So how do I find mass of liquid? Mass equals to rho v. This is the fundamental formula, right? So rho is already given, the density is 0.8. I need to find my v, which is the volume. Do I have v? Again, not directly out from the question, but we can calculate. So maybe I'll break it up so that's easier to understand. Volume of water is equal to what? How do I find? Alright, we use the base area multiplied by the length of the column. Okay, so this is actually under your math. I think in Sec 2 you should have learned this already. Okay, so if you forget, please do a recap. Alright, try to go and find out from your Sec 2 materials. So what is the volume of water? If you put these two together, I think you should get 3.1 cubic cm. Okay, then I want to find the mass of liquid, so now I can find, right? Mass is equals to rho v. Rho is 0.80. V, I just found it, is 3.1. Answer is 2.48 gram. Okay, seems pretty light, huh, for 12.4 cm of column. So they asked us to find the weight of liquid. Okay, formula W equals to mg. Recall, in the previous assignment I told you, right, the mass has to be in kg, simply because the value of the g given to us is 10, and then the unit is Newton per kg. This is very important. It's telling you every 1 kg is 1 Newton. So if you don't use kg, you cannot use the formula. Therefore, we need to change. Alright, how do I change from grams to kg again? Yes, we divide by 1000, multiply by 10. What do I have? 0.0248 Newton. Alright, this is it. Okay, next one is a higher order question. This is a 10-year series question. Okay, why is it higher order? Because you are given data. Okay, you are supposed to analyze data. Okay, so this is a requirement from Cambridge. We need to know how to analyze data well. Okay, so because the world, we have more and more data nowadays, so we must be good at looking at data and understanding what data really means. So for 1A, it says figure 1 shows how the volume of 10 gram of ice changes as the temperature rises from -10 to +10. And they say that the ice melts at 0. Okay, so during melting, okay, I think not sure if the physics the chemistry component has covered this, but during melting, temperature should remain constant. Okay, so calculate the density of ice at 0 degrees Celsius. Okay, so I want you all to be very careful about this. You see, at 0 degrees Celsius, basically is at which point? This part, right? So 0 degrees Celsius, I have a straight line here. the volume can be anywhere between 11 and 10, inclusive both numbers. Alright, so how do I know? Am I supposed to use 11? Am I supposed to use 10 or 10.2 or 10.5? Okay, the keyword is this, ice. So ice, it means that we are looking at the left portion. This is the ice. The right portion here is water, right? Because it has already melted, temperature is higher. So when we are talking about ice, we are talking about 11. We are using 11 as the point for the volume of ice. All right, 10 will be the volume of water at 0 degrees Celsius. Okay, so with that, density equals to mass over volume. What is the mass? 10 grams. What is the volume? We just said it's 11. So again, punch into your calculator, 3SF, some magic. This will be the answer, 0.909 gram per cubic centimeter. Okay, so some of you actually use 10 divided by 10. Okay, why 10? Because you decided to use this value instead. Because 10 divided by 10, I get 1 is easy, right? Okay, but that is not the case for this question. B is a description question. So describe means we want to see a little more about it. Don't just tell us factual things. You try to tell us what you see or what will happen to it. So describe how the density of the ice and of the water changes as the temperature changes from -10 to +10. And they say you should refer to the density changes, if any, all right, when it is ice. As it is melting, so we need to talk about it when it is ice, when it's melting, and when it is in water. All right. No further calculation is necessary. This is very important. They don't want you to do calculation, so we are not going to calculate. All right. It is not required of us. So let's take a look at -10 to 0. So -10 to 0 is this portion. Let me change the color. Maybe I'll use green. Okay. So we're talking about this portion. This portion is the ice, right? So from -10 to 0, what do you see? Is there any change in volume? No, right? It's a straight line. So since it's a straight line, it means that volume doesn't change. The volume doesn't change and mass is always a constant, so the density will always remain the same in this case, right? So we just have to say there is no change. In density, in the ice's density. All right, we don't have to give them a time frame anymore, the temperature frame anymore, because we are already answering to this, -10 to 0. Okay, how about 0? So now I need to change another color, purple. So this is the portion now. At 0, I have all the way from 11 to 10, right? So what happens to my volume? My volume did decrease from 11 to 10 as the ice melts. So since the volume decreases as ice melts, what happens to the density? Okay, I'm going to write it here. Density equals to mass over volume. Mass always a constant. If my density decreases, you divide by a smaller number, your density should increase, right? You divide by something smaller, your result will be bigger. The density increases. Is there a need to calculate? No. But if you want, you can. All right. So it is basically from 0.909. And then after that, you divide 10 by 10, you get 1. So you can say it increases from 0.909 to 1. All right. But there is no need to. For the third part, from 0 to 4. 0 to 4. Where's 0 to 4? 0 to 4, this is 2. Maybe 4 is around here. 3, 4. Is it here? No. 5, 2.5, 3, 3.5, 4. So it's here. Okay, I'm going to change color. Alright, I'm going to use blue. Alright, Look, so we're talking about this portion here. What happens to the volume? Again, volume decreases, right? So same thing, okay? Since the volume decreases, the density what? Increases. Can you calculate? Of course you can, but don't go and calculate every single one, just the starting and the ending point. Okay? How about from 4 onwards? From 4 onwards, we're talking about another color, yellow. Okay, from 4 onwards, we're talking about this portion, right? Oh yeah, so bright. So we're talking about this portion. What happens to the volume? I think it's quite obvious that the volume is actually increasing, right? So same thing. Since the volume increases, the density of water, in this case it's water already, what? Increase or decrease? Decrease. Okay? So this question I think is quite nice and quite nice to ask, because they actually did a scaffolding for us, because they break it up to 1, 2, 3 and 4. They tell you from negative 10 to 0, at 0, from 0 to 4, and from 4 onwards. The question can just choose to tell you describe from negative 10 to 10 without giving you this scaffolding. You are supposed in your answer include this on your own. So if you don't add this, you will not be able to analyze your data properly. You cannot answer it nicely. Okay, so yeah, you need to learn how to chop your data into pieces so that you can see them and answer them easily. Alright, that comes the end of your assignment 2. Okay, hope you guys are okay with this. If not, I'm just a call away. Alright, thank you.